All right, I think we are live. I think we're ready to go. So, I'm not sure if there are people here yet, but welcome. If you are just joining us, we are going to be getting started with the second installment of the South Carolina Sea Grant Consortium's weekly Educator Helpline sessions. So this is a new series that we're starting. Last week was our very first session. If you were able to tune in to that session, welcome back. And if you were not able to tune in, that's okay. It will be available on our website and on our Facebook page, so you can look back at our videos and look at the educational materials that we covered last week if you want to check that out, once we're done with today's video. So today I wanted to, we're going to talk about some buoyancy activities today, but before we get into that, I wanted to introduce myself and get to know you guys a little bit before we get really into all the activities that are behind me. So we wanted to know who's watching our videos. So if you want to share in the comments where you're watching from, or maybe where you teach, if you're a teacher, we'd like to get to know why this is of interest to you and how you ended up finding our page, so that we can make sure that we're providing something useful to you that applies to your life. So if you're a teacher who is looking for activities to do with your students, or maybe you're a parent just looking to occupy your kids at home, or maybe you're really bored and you just are wanting to do some ocean science related activities, we'd love to hear about it in the comments. So go ahead and share where you're watching from. Right now, I am in the office at our downtown office for South Carolina Sea Grant Consortium in Charleston. And I'm really, 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 really excited to be outside of my own home for the first time. And I don't know how long. I'm looking out a window, our skylight up top, and getting some fresh views and fresh perspectives, which is something that's pretty great. But this is going to be us showing you some activities that you can do from the comfort of your own home. So once I go back to my house, I might do some of these activities if I get bored. But we wanted to give you some support in doing marine science related activities in the comfort of your own home. So each week we're going to be presenting you with some educational resources that you can use, and hopefully you have all of the materials in your house already. And if not, we're going to try to come up with some substitutions for you guys. I actually had to do a couple of substitutions today so that I didn't go out to the stores finding the materials. And so we're going to talk about these activities. Today, all of our activities are going to relate to buoyancy. Last week, we talked all about marine debris. And then next week, we're going to cover some other marine science topic that we'll talk about at the very end. But without further ado, I want to explain the format of what we're going to be doing today, how this all kind of works, and what it's going to look like. If at any point you need to hop off and go wrangle your kids or thaw out some food for dinner or anything like that, feel free. The website will have this video hosted on it once we're all done with it, so you can check back and find out anything that you missed while we are going to be talking about these activities today. So today, our activities are all going to focus on buoyancy. We have a couple of write-ups for the activities. We're going to cover 3 different buoyancy-related activities, and all of them are in that write-up. We have 2 formats. One of them is a teacher formal lesson plan. So if you're a formal educator, or maybe you work in an informal education facility, you can use that, and it tells you all of the background information and everything you would need to know about who's doing what at what point. Or if you're just a parent looking for your kids to have some activity to do at home, we have a family version as well. So it's a little more pared down, simplified, so that you don't have to worry about all of the background information or the nuts and bolts of the educational activity. Those are going to be in the comments to the side, so you can follow along if you'd like to, or just watch the video, and at the very end, or next week when you're trying to do these things, if you need to remember what did we talk about, how did that activity work out, you can check that lesson plan and get some more information. So we're going to cover 3 activities for buoyancy, and then at the end we're going to cover a an art activity that puts those principles into practice and lets you do something pretty, hopefully it turns out cool. I have a couple of examples of my attempts that may or may not inspire you to do it yourself. But before we get into the buoyancy activities, I wanted to explain why we're doing them. Buoyancy is a really important concept in marine science, whether something sinks or floats. Being able to manipulate those properties of objects is really important for marine scientists, whether it is a researcher who's out at sea in the middle of the ocean on a boat that hopefully stays floating, or they're coming back into port and they need to dock that boat and put down an anchor that will sink down to the ground. Those principles of buoyancy are crucial to manipulate for marine science. Even scientists who are on land, if they're using data that was gathered by a buoy that is collecting information about weather patterns or currents or things that help us predict hurricanes, or maybe they're a pilot and working with a remote operated vehicle. All of those things utilize the principles of buoyancy. I'm not going to be piloting any submersibles or doing anything too complicated today. These lessons are going to be geared for 3rd through 8th grade, but you can kind of scale them up or down depending on the grade range that you're working with. If it's your toddler at home, then you can play with some clay and throw some stuff in some water and still have some fun without getting into the nitty-gritty of buoyancy. All right, so we're going to do an introductory activity where we look at some principles of different objects and what makes them float, what makes them sink, try to make some generalities, and then apply those to our next activity where we will try to take something that naturally would sink and make it float and try to do a little bit of a challenge to see how well it can float and how much it can hold. And then we're going to take it a step further. So if you have some students who are really, really intrigued and really involved in this and engaged, you can take it another step further and do an activity with neutral buoyancy. And then after that, we will get into the art project that will be simple and easy and make something cool. All right, so I'm going to step behind the activity table here. If you have any questions at any point, please feel free to put them in the comments. We've got Evie Bell, who you might have met last week, moderating those comments, answering your questions. So please feel free to ask her, or at the end, I'll do my best to answer any questions that come up along the way as well. All right, so the first activity that we're going to look at is examining the properties of some different household objects and finding out what makes them sink, what makes them float. And we're going to do that with some observations. Now, in the lesson plan, there is a student activity worksheet that they can fill out along the way, or you can write down some observations on a piece of paper that you have at your home. But the idea is you want to make predictions about different objects. The first pair of objects we're going to be looking at the principles of buoyancy with. In the write-up, it says a golf ball and a ping pong ball. That was one thing that I didn't have in my house. We typically have them around here, but we're using them for something else. And so instead, I looked around my house and I found a little rubber ball from a Jack's set. And then I made a little ball of clay. And that will work for this activity as well. So you can use things that aren't a golf ball and a ping pong ball. You want to have one that sinks and one that floats. But don't tell your student which one is which yet. So you're going to have these objects, present them to your student, and then you want the student to make a prediction. Do you think it's going to float, or do you think it's going to sink? Next, you're going to test that prediction. So that's all about making a hypothesis. Is what do you think is going to happen? Predict what's going to happen, and then test it. So you give them the object, they test it, and it floats. So you'll need a bin of water to do this with. You can use your sink, you can use a pot from your kitchen, or a pan, or a bowl, or really anything that you have. But you want something with water in it so you can test if they sink or float. So once they have observed that this ping pong ball or rubber ball floats, they're going to write that on their sheet in the observations section. You're going to continue that with some other objects. So next, looking at the golf ball or my clay ball, do I think this is going to sink or going to float? Now with the golf ball, that is something that often students get wrong, and it's important to reiterate that if their prediction is wrong, that's totally okay, and that is what science is making predictions and testing them. And if you're wrong, then at least you learned something. So now we're going to test our golf ball. and it sinks. If it were a golf ball, it would still sink. That one's kind of a toss-up because of the dimples on it, and it's not too heavy, so kids often think that they'll float, but I'm sure many golfers would tell you that if it lands in a pond or something like that, it will sink to the bottom, and they're going to have some trouble getting it back. Once they've observed that the ping pong ball floats and the golf ball sinks, you want to sort of delve into why is that? What's different about them? What's the same about those two objects? You want to have them look at them, and they should be roughly the same color. If they were actually the golf ball and ping pong ball, they would both be white. They're about the same size. And you want them to look similar, but have different properties. So the difference between these two things is the weight of the object, the density of the object. And that is a crucial thing in buoyancy, is the density and the way that it interacts with the water. The physical properties are very important for these objects. Next, you're going to look at another sort of area of category about an object, a characteristic of the object that will make it sink or float. And for this part, you'll need an orange or some other easily peeled citrus. You're going to have the student make this prediction again, do the same kind of thing. Do you think it's going to sink, or do you think it's going to float? Now, most people have not put oranges in water before, and so it's something that they might not have an idea of what it's going to do. But putting it in the water, it does float. But what's interesting about oranges is if you peel them, which is the next activity, and you put them in the water, now they sink. So when you peel the orange, you want to make sure that you get enough of the pith, the white foamy stuff, off of that orange. If you leave a lot of that pith, it will still float and kind of confuse the issue here. But what we want to demonstrate with this part is that adding weight doesn't necessarily mean that it will sink, because this is heavier than this without a peel. Taking away mass actually made this sink. So when we look at the ping pong ball and the golf ball, a lot of the time they're like, well, it's heavier, so it sinks. But this is heavier than this, and this one floated. So this is to reiterate that it's not just the weight or the mass of something that influences its buoyancy, it's the physical properties, it's the form that matters. A lot of times kids will say it's because it has air in it. Yeah, air floats, and that is a good observation, but you want to talk about the mass specifically with this one. In between those two, I skipped a step, but you can use a water bottle to talk about empty and full and adding weight so they can sort of get an idea of if you have something that is really dense, full of water, then you can see that it will sink. I didn't have a water bottle around my house, so this is another substitution that you can make. So you want to put it in the water full. So if you had a water bottle, you have a full water bottle, and if you put it in the water, it will sink. Now mine, I guess, has still a little bit of air still in it. It is floating a little bit, but a full water bottle will sink. And then if you take the water out and put it back in, now it will float. This will give them some ideas for building the next activity, which is applying some principles of buoyancy. So based on looking at this orange and looking at this ping pong ball and golf ball, what kind of things can we say about what makes something float? Is it having air in it? Is it the shape of it? Is it the size of it? Is it the mass of it? And maybe one day we'll get some things like this to float on the wall and not hit us in the back. All right, so our next activity, once we've made some of those observations about what makes things sink or float, we want to put those into practice. So this is going to be the clay ball challenge. For this activity, all you need is a clay ball that is about the size of a golf ball, maybe a little bit bigger. And then you'll need some pennies or some sort of weight so that you can put into that clay once you finish with it. So you're going to give this clay ball to the student and have them make a prediction, form a hypothesis of, do you think this thing is going to sink, or do you think this clay ball is going to float? So looking at it, what's your hypothesis? And you can have them form a hypothesis in an if-then statement. So if I put this clay ball in the water, then it will sink, or then it will float. And then once they've formed that hypothesis, have them test it. So take that clay ball and put it in the water, and it will sink. Now the challenge comes in with taking the things that they learned from that introductory activity and trying to apply them to this clay ball. What can they change about the clay ball that will make it float? They have to use the entire ball of clay. So a lot of times kids just say, oh, well, it's too heavy. It's too heavy to float. And so they want to take some of the clay away. But in order to satisfy the challenge, they have to use the entire ball of clay. When kids do this, there are plenty of designs that you can make, but typically they'll try flattening it out first and making just sort of a raft of clay and putting it directly into the water and hoping that will work. It, spoilers, does not work. It will still sink. And so you want to give them some time to think about it on their own. If you have them draw out the design beforehand, it gives them some time to process, okay, what do I think a design would look like in order to make this clay ball float, and then put it in practice. Once they do their first design, did it sink, did it float? Rarely students will get it right on the first time, but most of the time it'll still sink, and then have them improve it from there. You want to give them time to improve it on their own without giving them too many hints and too much help, because you want them to think about it and really come up with these things on their own. If you have a student that is really struggling, then you can give them some hints. I wouldn't say, well, maybe if you make it into this shape, but have them think about some objects that they're familiar with that float, and what about those things floats. Some useful objects. Obviously, we talked about the objects before with ping pong balls and golf balls, but if they make it into a hollow ball, it might work, but it will be tough for the next set of instructions, which they don't know about yet, so it's okay if they make that and that floats. When they finally come up with a concept, a design that floats, typically it'll look something like a little cup or a boat, which is perfect because after they make it float, you want to have it stable for about 10 seconds at least, and then you're going to add a challenge to it. In engineering and in science, typically you have a stated problem, or you have something that you're trying to figure out, a question that you're looking for an answer to. You're going to give them the challenge of putting weight into their clay ball. You want to see how much weight they can hold and optimize their design. For this, you can use pennies, you can use little glass weights, you can use basically anything kind of uniform that you have around your house. I had pennies, and so you can put those pennies into your design, count them up, and see how many it can hold before it starts to sink. I'm going to grab a sip of water real quick. Excuse me. And so those pennies are going to act like the load. So say you're designing a cruise ship or you're designing a research vessel. It needs to have a payload. It needs to hold things in order to be useful. So having something that just floats is great, but you need to take it a step further in order to make it useful for science. If you have a class of students, you can turn this into a challenge between the students. So you can have them see who can hold the most pennies. A lot of kids will get really competitive with this activity. But you want to encourage your students as they go through it and really say, identify the issues with your design, where is water coming in, and help them through that engineering and that design process so they can build something that will hold a lot of weight. And they feel like they've accomplished something because they totally have. They've made something not buoyant into something buoyant. So if you have a student that is really jamming with this, having a great time with that activity, you can take it a step further. So what we've been doing is making things positively buoyant. When something is positively buoyant, it floats. It stays on top of the water. The buoyant force is outweighing the negative force of gravity that is pulling it down, and so that force is pushing it to the top. When something sinks, it's negatively buoyant. So the weight, the force of gravity, is pulling it down more than the buoyant force is pushing it up. So that would be when it sinks. When something is neutrally buoyant, it's going to be in the middle of the water column. Rather than floating at the top or sinking to the bottom, it's going to stay sort of in the middle. It's not going to sink, and it's not going to float. Making something neutrally buoyant is actually really tricky. This is an activity that we do when we go to science nights or 20, 30 minutes. It can be a good time to accomplish this. So you want to give this to students when they have a chunk of time and when they're really feeling up to a challenge. To make something neutrally buoyant, you can use really anything that you have around your house. In this bag, I have a sponge like this, which would be positively buoyant. I have some corks. You might have some of these lying around your house these days. I don't know. And then some negatively buoyant things as well. Things like toothpicks or maybe paper clips or some screws or nails or washers. You just want to have a mix of positively buoyant and negatively buoyant objects so that you can put those together into one thing that they can put into that water and test and see if it will be positively buoyant, negatively buoyant, or hopefully end up neutrally buoyant. Neutral buoyancy is really crucial for remote operated vehicles, those submersibles that you see going down to deep sea environments in the ocean and sort of looking around at these really, really fragile environments. Those are hovering right above that sand or that sediment or that rock, that coral, and they can't hit that. So you want to have something that will stay right where you want it to. Maybe you can manipulate that buoyancy, go up by putting some air into it, or go down by adding some weight to it, some ballast. All right, so those are 3 pretty simple activities that you can do with your kids at home, all using the principles of buoyancy. And then if you're still looking for some stuff to do, some ocean science related activities that you can use that as an excuse to make something fun and cool in your home, you can use those principles of buoyancy to make a homemade lava lamp and an art project. So we're going to do the lava lamp first. In here I have just some water with some food coloring. I did blue because I am an ocean science person. And then I also have some canola oil as well. So you want to add some oil to your jar or your container. If you used a water bottle earlier for that floating and sinking activity, you can use that again, really reuse that single-use water bottle. And so you're going to put some of that oil into your water. And we all know that water and oil don't mix. If you've ever had salad dressing, you know this, but they won't mix. So you'll have a layer of oil and a layer of water in your jar. And the thing that you may or may not have around your house is some Alka-Seltzer. So when you put that in there, that oil is more buoyant than the water. It's less dense. It rises to the top. And what you can do to optimize and to use those principles of buoyancy to your advantage to make something pretty neat, I'm going to bring this up so you guys can see it. When you put some Alka-Seltzer in there, it starts to bubble and fizz, and you have your own lava lamp. That water is coming up, it's bubbling into the oil and falling back down as it reaches the surface and lets those gases out. So you can do that with your kids. You can get as far into the principles of buoyancy as you want. You can talk about the density of it and how the density and the weight impact the way that something floats or sinks. Or you can just have some fun with it. Put that into your jar, your container, and just make a fun lava lamp so that it looks kind of cool. If you don't have the Alka-Seltzer, you can put a cap on it and just shake it up and watch those water bubbles move in the oil without having to need Alka-Seltzer in your home. All right, the last activity is actually my favorite one. I used some oil and some water and a baking sheet. Those are the only things you need, and some sort of coloring. So I have food coloring again, same food coloring I used for my lava lamp. And what you're going to do is you're going to take some food coloring and put it in a baking sheet with some water. Now I think I'm going to do some blue and some green because, again, ocean. So you just want to put some of that food coloring in there, stir it up, and then you're going to take some of your oil, again, that you used from your lava lamp. You can use a spoon or an eyedropper. I have a little syringe here from CVS. And then you want to put some oil on top of that water. Because as we saw with the lava lamp, the oil is more buoyant. It's going to float to the top. It's going to stay on top of that water, and you'll end up with little oil droplets all over the surface. You can be liberal with this. You can put a lot of oil. You can put a little bit of oil. It's kind of up to you what kind of result you want to end up with. Then you're going to take a sheet of paper. If you have some sort of heavy cardstock or some just plain paper, that works too, computer paper. If you want something a little heavier is better. And then you're just going to take it. I'm going to swirl out my color a little bit here and plop it on top of the baking sheet and take it back off of that baking sheet. Now what you'll end up with on your piece of paper is drops of nothing. Those are where the oil was staying, and then the food coloring water or the watercolor paint water is going to color in the rest of that area. If you've ever seen papers that were marbled on the front of old fancy books or things like that, this is kind of the way they did it. They would use different kinds of paints, but they would swirl it on top of water. I made one yesterday. I'm not sure if you'll be able to see it or not. Let's see here. But it ends up having these really neat marbled patterns in it. So you can use this to maybe write some letters to your quarantined relatives who are looking for some human interaction. You can use it to just do something fun with your kids and talk to them about how things sink or how things float, and how when you do a belly flop in the pool, it's just going to smack you right back, and that's that water, that buoyant force hitting you back when you are coming into the water. So I would like to ask you guys if you have any questions. We want to keep it to about half an hour today, so we've got a couple of minutes left. If anybody has any questions, either put them over in the comments or you can email me and Evie. If you want to look back at this activity or any of the things that we did, that is in the links in the comments, so check that out. I'm going to give it a sec because there's a weird delay with Facebook videos. Sometimes it takes a minute for questions to come through, but we'll give it a second here. All right, I'm not seeing any comments yet, so we'll just go ahead and close out the video. If you would like to check out those activities, remember to click the link or go to our website, sccgrant.org/education. But thank you so much. Next week, we're going to be talking about ocean literacy principles. We have our first set of activities that are all aligned to the ocean literacy principles, and that is going to be coming on Thursday next week, same time, same place, maybe a different face. But thanks so much for watching. Thanks for joining us. Oh, I have a question. All right. If you don't have clay, what can you use? All right, so that's a good question. Basically, you want to use any kind of pliable material that you can put into water. Play-Doh is not going to work that well because it does start to disintegrate. You might be able to use it for a short amount of time, but that water is going to get to it and going to cause you some problems. If you have some Sculpey, that's clay, but that foamy Crayola material that you can mold, you want something moldable that goes in water. So that foamy material, that works really well. There might be some other materials like rubber erasers. I've seen some of those that you can mold and change the shape of. But basically, as long as it can go in water and not fall apart and change shape, that will work for you. Great question. All right. If there's nothing else, thanks again for watching. This video is going to go up onto our Facebook page and onto our website so that you can check back and see that poster fall again and check it out and learn anything that you missed along the way. I know I sped through that kind of fast, but thanks for bearing with me for watching our video today. And can you explain what makes something neutrally buoyant? Absolutely. Okay, so when we talked about those forces, so the water is pushing up, that's the buoyant force. I'm gonna draw a little diagram for you here real quick. I am not a physics teacher, believe it or not. You can probably believe it from the way I tried to attach that poster, but this is my best force diagram. So you have an object here in the middle, and then there are different forces acting on it. I'm simplifying this a lot because I don't want to get into friction and drag and all of that kind of stuff. But basically you have FB, which is that buoyant force, the water or that fluid pushing up on the object. And then you have force of gravity, the weight of the object that is pushing back on that buoyant force. When you have something positively buoyant, that buoyant force, that upward force, is larger than the downward force, larger than the gravity. When you have something that sinks, that's negatively buoyant, this force here is greater than the upward force. When something is neutrally buoyant, it's going to be equal. The force of gravity, the downward force, is the same as the buoyant force, the same as that force that is pushing it back up. You can see this in fish. Fish use a swim bladder in their body. It's a pocket of air that they can manipulate. That swim bladder is going to inflate or deflate as they go into different pockets of water that have different densities. You want that force to be equal, so they're constantly monitoring it because there's different pockets of water in the ocean, different salinities and temperatures, things like that. That'll all change the buoyancy of something. So a fish can change on a moment's notice its buoyancy and change how much that upward force is, how much they are floating versus falling constantly into the water. When you see sick fish, you'll see they're either floating to the top or some of them will start sinking down. A lot of times that'll be because they're not regulating that swim bladder very well. Scuba divers also maintain neutral buoyancy when they've really got it down, and that's going to be controlled by the air pocket that they have in their buoyancy control device, that vest that they wear, and then they'll also use weights as well. So it's a matter of balancing the upward force, that air, that negative, that upward force that's pulling you to the surface with the downward force. So you don't want to put a bunch of air into your BCD, your vest with all the air pocket, because you're going to shoot right up to the top, and we're full of air pockets that are going to give you some problems. But they'll use weights as well to hold them down and balance that as they go. So living things and non-living things like those submersibles have to be neutrally buoyant, and it's pretty tricky. I've seen some kids trying the activity that we talked about today, work on it for 20 minutes or so and still just be starting to get it right. So it's a really good way to occupy some time in your household. You can yourself if you would like to. Yeah, same time, same place next week. And the topic is going to be Ocean Literacy Principle number 1. So we're going to start shifting. There's the Ocean Literacy Framework, which is a set of science standards that were developed so that teachers could have a formal progression of information about the ocean and the way to present it in a classroom. And so Ocean Literacy Principle number 1 is the Earth has one large ocean with many features. And so we're going to be talking about those features, getting a little more into density. Today we talked about buoyancy, and density absolutely influences the buoyancy of an object. So it will be here, 4 o'clock. So join us again next week, and we'll see you then. Thanks so much for coming, guys, and for watching. We'll see you next week.